There we go. All right, everyone. Welcome back to the land of Chem. I'm your host and the author. My name is Jeffrey Drum. Thank you all so much for joining me again. All right, everyone, welcome back. And this week I have a spectacular two-part series prepared to celebrate episode 100 here on the Land of Chem YouTube channel. This week is part 1, and I will be explaining the function of the Great Pyramid's antechamber as first introduced back in episode 89, discussing the inverse piezoelectric property and ultrasound. And ladies and gentlemen, if you haven't already, now is the time to subscribe and click that little notification bell, because part 2 of this week's celebration will feature the exclusive footage from my private special permission access into all 3 chambers of the Great Pyramid of Giza at night. That's right, everyone. I was granted permission to access all 3 chambers of the Great Pyramid in a private special permission at night from 8 p.m. until 10 p.m. And it was by far one of the most memorable experiences of my entire life. If you want to help support this channel and my research efforts, please check out the Land of Chem members only channel. This month, I will be releasing the full chemical analysis of the iron oxide deposits from around the trial passages and the never before seen footage from my expedition to the Lost Pyramid in Dashur. If you want to grab a copy of the book and pick up some merch, just check out thelandofchem.com. If you want to follow me on Instagram, my handle is @thelandofchem. Ladies and gentlemen, I think that is it for today's intro. So without further ado, episode 100, let's get right to it. All right, everyone, here we go with tonight's episode. And let's start this one off with a bang and get right to the point. The antechamber of the Great Pyramid of Giza is an acoustic catalyst chamber designed to generate ultrasonic frequencies that facilitate the conversion of sulfur dioxide into sulfur trioxide in the production of a dilute solution of sulfuric acid. If you were paying attention during last week's Sunday site visit, you may have heard me describe the functional properties of the various types of stone that are encoded in the colors of each material. As presented in episode 88, Functional Pyramid Stone, Part 1, Black Basalt. If you see black stone, think thermoregulatory and heat retention properties. If you see white stone, think dielectric properties. More on this coming up soon. And if you see red stone, specifically relevant to today's episode, red granite, think generation of ultrasonic acoustic waves. Red granite is a fascinating, functional material that is composed mostly of quartz embedded within a matrix binder of feldspar and mica. And the alchemical magic of this stone exists within these pieces of crystalline quartz. The biggest misconception about the function of the Great Pyramid is that the red granite is used to produce electricity via the piezoelectric effect, where mechanical force is applied to the surface of the crystal, which elicits an electric charge. And most would tell you that the pressure from the weight of the stone above these chambers is this mechanical force. However, constant static pressure that is distributed through the matrix material of the red granite is not going to produce any piezoelectric effect. If it did, it would still be happening today, and you would be getting zapped with electricity every time you touch the walls of the chamber. And I can assure you, this absolutely is not the case. The function of the red granite stone within the Great Pyramid of Giza is the exact opposite. It is the inverse piezoelectric effect, where a voltage is applied to the crystal, causing it to change shape, producing ultrasonic vibrations. As explained here, and I will quote, "The property of certain crystals to expand or strain when positive or negative electric current is applied. Voltage applied to opposite sides of the crystal, causing it to expand. polarity is reversed, causing the crystal to strain. Constant change from expansion to strain, strain to expansion results in mechanical waves, i.e. sound, being produced. Thus, the electrical signal is converted into a sound wave. And this is exactly how our modern ultrasound machines work, where an electrical current is applied to the quartz crystal within the machine, causing it to vibrate and generate ultrasound waves, high-frequency acoustic vibrations. So now let me show you a clip of an experiment where this property is demonstrated in the proximity of an electromagnetic energy field, similar to that which is generated by the Earth itself. For more on this, check out episode 79, link in the video description below.
There we go. And you can see the two combinations of stone here, the first being the limestone and black basalt. Even with the combination of the two stones, the electromagnetic current is still flowing through the stones and producing an equal amount of discharge, whether it be just the limestone itself or the combination of limestone and black basalt.
And then we go to granite.
The granite has an extremely high quartz content, and the quartz inside of the stone are trapping that electromagnetic energy inside of the stone and producing vibrations. You can feel, if I put my hand near this thing, I can feel the vibration coming off of this stone pretty significantly. But if I touch this, it's probably going to shock me. There we go. Yep. And you can hear when it produces that discharge.
All right, now, these high-frequency acoustic vibrations, or ultrasound waves, are a powerful tool when it comes to chemistry. And the antechamber of the Great Pyramid is teeming with these red granite crystal quartz transformers. Not to mention, the dimensions of the cavities themselves have been tuned to amplify the sound waves produced therein. And I can tell you from firsthand experience that if you stand right here between this granite leaf and the north wall of the chamber and do some slight humming, it will generate sound vibrations so loud and profound that it will not only change your body, but it will change your life forever. And this spot specifically has the most significant acoustic amplification properties found within this entire pyramid. So now, what does ultrasound have to do with chemical reactions? Well, ladies and gentlemen, this is episode 100, and it will now be my pleasure to blow your minds. Allow me to introduce you to a topic in a field of research known as sonochemistry. And it is exactly how it appears, sound chemistry, as defined here. Sonochemistry is a branch of chemical research dealing with the chemical effects and applications of ultrasonic waves, mostly in the production of nanomaterials, as you can see here, a topic that I will be returning again to soon. And as you can see here, sonochemistry was one of the earliest techniques used to prepare nanomaterials. Sonochemistry is the research area in which molecules undergo a chemical reaction because of the application of powerful ultrasound radiation. The physical phenomenon responsible for the sonochemical process is acoustic cavitation. And here is an image showing a solution containing dissolved metal particles being irradiated with high-frequency vibrations in this ultrasonic bath. This should be sounding very familiar, especially if you saw episode 1 on my members-only channel. And this is a process that I will also be returning to again soon, exclusively for the initiates. Link in the video description below if you want to help support the channel and get access to that fire on the private channel. But for now, let's focus on the antechamber and sonochemistry. So the red granite within this acoustic catalyst chamber, the so-called antechamber, was utilized to produce ultrasound, which can have significant effects on chemical reactions. And I will quote here, "Sonochemistry is the use of ultrasound to enhance or alter chemical reactions. Sonochemistry, in the true sense of the term, occurs when ultrasound induces true chemical effects on the reaction system, such as forming free radicals, which accelerate the reaction. However, ultrasound may have other mechanical effects on the reaction, such as increasing the surface area between the reactants, accelerating dissolution, and or renewing the surface of solid reactant or catalyst. Furthermore, sonochemistry, and I will quote here, the term sonochemistry is used to describe a subject that uses sound energy to affect chemical processes. This terminology is in keeping with that of the longer established methods that use light, i.e. photochemistry, and electricity, i.e. electrochemistry, to achieve chemical activation. It might be argued that a more accurate description of the subject would be cavitation chemistry, since the majority of applications rely on the energies generated by acoustic cavitation. However, sonochemistry is the established term, and certainly over the last few years, giant strides have been made in this subject. Gone are the days when sonochemistry was considered to be a quote-unquote black art, and simply a method of initiating intransigent reactions, particularly those that depend on activation of metallic or solid reagents. There it is once again, the quote-unquote black art, ancient alchemy, bringing us full circle for the second time in my research to one of the first slides that I ever made for the land of Chem, explaining the play on words that was the genesis for the title of my book. The first time being when I discovered the connection between the ancient word chem, meaning blackness, to the black sand mineral deposits which were abundant with the heavy metal ores that were found in the chemical analysis of the red pyramid staining. This extremely valuable material that also contained the ilmenite iron titanium ore that enabled cutting of these red granite stones. And of course, the title of my book, The Land of Chem, being a play on words for this ancient word Khem, meaning blackness, but chem for the land of chemistry, the land of this quote-unquote black art of sonochemistry, ancient alchemy as facilitated by acoustic vibrations, which leads us here. And I will quote, "Catalytic oxidation of sulfur dioxide by oxygen in an aqueous solution of sulfuric acid in the presence of bivalent manganese ions under ultrasound irradiation," end quote. Yep, you heard that correctly. And this is just the beginning. So now back to the configuration of the antechamber and the function of the Great Pyramid. All right, everyone, just a quick reminder that if you want to help support the channel, just check out thelandofchem.com. I have the new 6th degree green lion logo, the 5th degree central pyramid hydrochloric acid logo, the new 2nd edition print copy of the Land of Chem book, this beautiful new Egyptian blue edition, signed copies, extremely rare, only 89 copies in existence of the original 1st edition purple orchid paper print of the Land of Chem book are also available all at thelandofchem.com. So if you want to show some love, just check out the website. And from the bottom of my heart, thank you all so much for the support. All right, here is the southern wall of the antechamber that features these 4 tapered grooves with the smaller end here and the larger end here. These grooves allow the flow of sulfur dioxide gases to move from the furnace chamber or the king's chamber up into the cavity above the antechamber, as you can see here. And the evidence of the catalytic oxidation reaction that began to occur in this chamber is abundant in the oxidation covering the piece of limestone that is located right here, as well as throughout the roof of the antechamber. And I will put in a clip now so you can see it for yourself.
You can see inside of this chamber, as with in almost all areas of the Great Pyramid, there is pretty significant oxidation here. You see there? And you see that all throughout the Grand Gallery. So again, we're taking the same passage that those gases would have flown through, and this is a passage that was excavated around the antechamber. And you can see here, this is where those gases would have dropped down. So this is also in the antechamber here. This is looking back to where we just were. You can see those grooves on the other side of this stone partition. The gases would have flown down through here, passing through into the contact process chamber.
But remember, this chamber was blocked with 3 huge pieces of granite, which served a dual function. First, to seal the acoustic catalyst chamber and isolate the reaction space, separating it completely from the sulfur furnace on the south side and the contact process chamber on the north side. And second, to increase the quantity of crystal quartz acoustic transformers inside of this chamber, which exponentially amplified the production of ultrasonic vibrations within this portion of the reactor. The more quartz, the more sonochemical catalyzation of your reaction, transforming sulfur dioxide into sulfur trioxide. So here are our 3 red granite slabs, and the only thing that could flow through these grooves is gas being pulled through the antechamber as the water level was being dropped inside the contact process chamber, a mechanism that was explained in episode 80, Why is the Grand Gallery Slanted? Also linked in the video description below. All right, now we have the sulfur dioxide gas being pulled through the grooves into the antechamber above the 3 granite slabs. And as I explained before, in Sunday Site Visit 26, I do not think these semicircular housings have anything to do with a wooden beam and rope system. And I do not think these red granite slabs were ever intended to move. They are not a valve system like we have seen in other pyramids, but rather immobile, fixed into place and installed during the construction of the entire pyramid. The same with the container inside of the quote-unquote king's chamber, which was not moved into the furnace chamber, but rather installed into place while the chamber was under construction and still open to the air at the top. And just take a look at the current state of these semicircular housings. They are by no means precise or even like the masonry that we just saw in the image showing the northern air shaft, which was meticulously engineered and executed in the construction of that component. These semicircular housings look somewhat destroyed, as if something was removed from these housings. So here we have the high frequency acoustic ultrasound waves being generated by the quartz crystal inside the red granite, being amplified by the geometry of the chamber itself, producing an effective sonochemical catalyst for the oxidation reaction that transforms the sulfur dioxide into sulfur trioxide. As the gases flow through the upper part of the chamber, and you can see here, the red granite slabs may have been capped as depicted from this article by Ephraim Pachin, which would explain the partially destroyed state as the cap was removed. The question remaining, what was that cap over these stones made from? So the sulfur dioxide gases flow through this acoustic catalyst system and are drawn down into this opening between the granite leaf and the northern wall of the chamber, where the quote-unquote boss, or as I will henceforth refer to it as the node, is located. And I believe that these structures are encoded with information that explains their operation, and the terminology of node not only being perfectly descriptive of this feature, but also in the operation of the chamber as this quote-unquote boss indicates a node of the ultrasound waves being generated in the antechamber. And this boss or node is located here on this granite leaf. All right, now let's review the entire system. The sulfur dioxide is pulled from the furnace chamber into the acoustic catalyst chamber as the water level is lowered in the contact process chamber, and it flows over the 3 red granite slabs, exposing the gas to ultrasonic frequencies being generated by the quartz crystal, causing a sonochemical reaction that oxidizes the sulfur dioxide into sulfur trioxide. As the water level in the contact process chamber is further lowered, the gases are pulled out of the antechamber into the contact process chamber, leaving us with a mixture of sulfur dioxide and sulfur trioxide. Here in this image, I have depicted the 3 red granite slabs being short, as suggested by some researchers who subscribe to the rope and pulley idea. And here, going all the way up to the semicircular housings for the caps as proposed by Pachin, in my opinion, a more accurate representation of the chamber's original configuration. The water level, as you can see here, is then raised again within the contact process chamber, bringing the water into contact with the sulfur dioxide and sulfur trioxide, producing an intermediary product known as sulfurous acid, or H2SO3. The sulfurous acid is then immediately further oxidized by the acoustic cavitation within this aqueous solution, transforming the sulfurous acid into the final product, a dilute solution of sulfuric acid, H2SO4. So now, this is your first introduction to another reaction mechanism called acoustic cavitation, which will be extremely relevant to upcoming discussions. And there are still more mechanisms of operation to explain regarding the function of the contact process chamber. So please subscribe and stay tuned. All right, everyone, that is it for today's video. This was episode 100. Sonochemistry, the acoustic catalyst chamber of the Great Pyramid. I really hope you enjoyed today's video, and now that your minds are thoroughly melted, prepare yourselves for Sunday Site Visit 28, featuring the footage from my special permission access, private access into all 3 chambers of the Great Pyramid of Giza at night. I can promise you this is something you will not see anywhere else. So if you haven't already, please subscribe to The Land of Chem here on YouTube. Click that little notification bell and stay tuned. If you want to help support the channel, check out the Land of Chem members only section for exclusive research-related content and unreleased footage that you will not see anywhere else. If you want to grab a copy of the book or pick up some merch, check out thelandofchem.com. If you want to follow me on Instagram, my handle is @thelandofchem. Also, check out our new YouTube channel, Egypt Eats, for food reviews from all of the exceptional restaurants here in Egypt. Ladies and gentlemen, I think that is it for today's video, so I will see you next time.
Yo, are you still watching this? Please subscribe to The Land of Chem here on YouTube and click that little notification button. New videos coming out every single week. And check out this other episode. Come on, do it. Do it now.